stop screen the whole computer. I don't know why. This is fun.
So, question 1 and 2 are easy. It's just if you participated and did the individual assignment. But I'll go ahead and read question 3. It says, in a pie chart, why are there slices different sizes? Or the sectors different sizes?
On that one, I got the third answer, I think.
Yeah, me too.
Yeah, me too.
Sorry, guys. I'm just barely trying to re-pull it up because my computer just restarted. So. But everyone thinks it's the third answer?
Yep.
Yeah.
Okay.
I started going through this quiz before we got on here, and it's not that difficult,
That's good.
so it shouldn't take us too long.
Like the other ones have?
You mean last week?
Yeah, those ones kicked our butt, man.
Seriously.
Even though we did well.
Yeah.
Okay, I'll read the next question. How are bar charts and Pareto charts related? So, I think is it the
Third one?
third one? That's what I think it is.
Yep.
Yeah.
Okay.
Okay. So number 5, is P the true proportion or the sample proportion?
This is tricky. I think they're trying to throw us off, but I got the true proportion on this one.
Why is
How
that?
did you
Yeah, because I was thinking it's a sample, but then I don't know how to explain if it just
Well,
seems like
the sample one has the triangle over the top of it, and
Oh,
that one's the one where you get the amount of times divided by the sample size. But this is asking what P is.
Mhm.
P is the true proportion, and that's where you find it inside this normal distribution.
Okay.
That's what I got. I don't know if you guys agree or not.
well, that makes sense the way you explain it. So,
And number 6 is the sample size?
Yep.
Okay. If P equals 1/4, what is the smallest and that satisfies a requirement?
For this question, you basically have to go up to that formula that it shows us to show when the sample proportion is normally distributed.
Mm-hmm.
And for it to be normally distributed, it has to be greater than or equal to 10 on both sides. So basically, that's the sample size times the true proportion has to be greater than or equal to 10.
so
where you find
40?
the smallest that it can be is, you said 40, Kazuya?
That's what I said as well.
Okay.
Yeah, because if you plug in 40 times 1, then
1/4, yeah. I just multiplied 40 times 0.25 and it gave me, 40 times 0.25 and it gave me 10.
oh, because you did algebraically.
Yeah.
Okay, that makes sense. Yeah.
What were you
Wait.
asking, Jeremy?
where are you looking at this on the online textbook?
It's on the online textbook, but you can also see it right before the question 5. It's telling us the formula to get the normally distributed sample proportion. And that's basically what we're trying to figure out is whether or not.
Okay. So you do what is it? Where's our you do
Are we
I'm on the
still
wrong
on 7?
question. Are we on question 7?
Yeah.
Yeah, we're just,
Yeah, we are.
just asking
Oh.
questions about it.
I was looking at question 8. Sorry.
Oh.
I was like, I was so out.
I know, because I was like, what? I didn't really understand what was going on.
So you said you got 40?
Yeah, because you multiply 40 by 1/4, which is the true proportion. So I just did it like it says in that formula where you do, 40 times 0.25, that gives you 10 exactly. So it's equal to it. So it has to be at least 40.
Because it can't
You're
be
saying-
below 40
Yeah.
on the answer, right? Because
Yep.
when you do algebraic. Okay. So the next one is, what is the mean of P
Excuse me.
on top?
Do we just multiply these two? Or, I don't know.
Because we got n equals 24, and then we got P equals 410.
So I got, if we're multiplying these two, I got 9.6.
That's what I did too.
Okay.
So I don't know if you guys are looking on the textbook, but on here it says when the sample is normally distributed, the true population mean of the random variable p is the same as p. So the p with the triangle on top also is p. I don't know if that makes sense.
So if that's it, is that the correct answer when we multiply though, or is it not multiplication?
No, that part's not multiplication, and I haven't found a place that says, where to get, because it's not giving us a certain amount that we multiply by, because you don't have like a sample mean to divide by, or you don't have like another number to divide. So we just have n and the normal probability, or the true population. What is it called? True proportion.
Yeah, true proportion.
And you don't multiply the true proportion inside the actual formula for P. So I put 0.4 on that, but
0.4.
I see what you're talking about.
I can see what you're saying on that one.
Yeah, I think that's the best, yeah.
If we get it wrong, then we can come back.
yeah.
We can always do that.
So then we have to find the standard deviation. Is that gonna be, take the 20, let's see.
Standard deviation is the square root of the true population times 1 minus the true population over the sample size. Well, I put mine in inside an Excel spreadsheet. I just did two formulas. One, I did a square root, and then I did the
And what else? Okay.
true population divided by the sample size. And I got on that one, I got
0.4.
0.1 on that.
0.1?
0.1. Let me make sure that I get it right.
Yeah,
That sounds right to me. Because were you able to look at it too?
I am just doing it.
I got 0.1 too.
Did you say 0.1?
0.1, yeah.
I got 0.01.
0.01?
Are you rounding it to the nearest 10?
Oh, I didn't do the. I
You
didn't
have to
do
round
the
it to
square.
the nearest. Yeah, you got to round that number. Sorry for the background noise, guys. I'm in the ice center right now. I was just playing basketball.
I got
I got
I
point
still
one
got
too.
What'd you get?
I got point one.
Okay.
I didn't square it, so
Oh, okay.
Gotcha.
Okay.
So the next question, Brittany's batting average is 0.3 or 30%. We want to determine the probability that she will get more than 35 hits in her next 100 at-bats. So our sample size is 100, and our true proportion is 0.3. What is P?
Would that be 0.3 again?
So it could be 0.3, but it also gave us 35 hits in
Yeah.
100 sample size, and I got 0.35 on it. So I guess we could try either or.
So how did you get 0.35? Because you did it out of 135 out of 100?
Yeah, because you do that same thing to find
that
that
makes sense.
proportion.
That makes sense.
So I got 0.35 on it. If it's wrong, we can do the 0.3 on it. But it
Okay.
almost seemed too simple to do 0.3 on that one. I was like, why?
But if it says 2 decimal places, I would think we'd use 2 numbers. Do you know what I mean?
Yeah.
Yeah,
Could be
that's
2
why I
different
thought
numbers.
weird.
Yeah, that makes sense. Man, Brittany,
And then question
better based
11.
off
She's
than,
good.
better than me, no?
Okay, what's the standard deviation of the sample proportion?
I got 0.046.
That's also what I got.
Okay,
And how'd you guys do that one?
You do the same thing you did in that one thing where you do the square root of
Oh, the
P.
square root. Okay. That one
Yeah.
formula?
Yeah, that one formula. And that comes out to 0.046.
No, like
Well, it comes out to like 0.458, but you have to round up. So
value.
So it's 0.46? That's to the 3 decimal.
0.046.
Okay. Oh, 0.046. Yeah? Basically. Yes?
Yeah.
Okay.
Yeah.
Just making
Sorry.
Sorry.
Man, I don't want to be that guy again where I check our score and then I get one wrong and we're not supposed to get it wrong. What else happens to me? Put the wrong
Okay, question 12 is what is the Z score?
So, Thomas, do you see where it says the Z-score, like the formula?
Yeah.
Do you see how it says the P with the triangle on top minus just the normal P?
So we can get the Z-score from just doing that?
Yeah. Yep. So you take the P minus normal P,
0.3.
and then you divide it by the standard deviation, which we already have. So if it's 0.35 minus 0.3 divided by that standard deviation, I got 1.091 on that.
Yeah, 1.09.
1.091.
1 second. Let me do that real quick. I just want to. What did you say you got?
1.091.
Yeah, that's what I got too.
Hold on, I'm putting it in right now. So, 1.091.
Yep.
Yeah.
Okay. Okay. What is the probability Brittany gets at least 35 hits in her next 100 at bats?
Yeah.
Wait, how do
So
we get?
on this one, I use the normal probability
Oh,
output
okay. Oh, yeah.
because we already have the Z-score. So you just put the Z-score in.
Oh, you just put the Z-score and then you shaded it in, or?
Yeah, but this is where I'm kind of confused on it because it's saying at least 35. So doesn't that mean it has to come up to at least the right side where that Z-score is?
Yeah.
Yeah.
But
Yeah,
everything,
They did left side, everything.
everything's shaded to the left side of that Z-score.
Yeah.
Yeah, that should be
So
right.
I got 0.862.
Yep.
You guys agree
Same
with that?
here. Yep.
Where did you find that at again?
It's at the probability appellate thing.
Yeah, pull up that probability applet that's at the
Type
top
in
of
the
this.
Z-score.
Oh, you're using that? Okay.
Yeah,
Yeah,
Shade
we
everything
just got
to the
our
left of
Z-score
it,
on
and
it, right?
that's what you should get.
Yeah. So we just got our Z-score on it, and then basically we just came to consensus that you put in your Z-score, shade everything to the left of that Z-score, and then that should give you the area, which turns out to be the probability.
0.862, right?
Yep.
Okay.
So the p with the triangle on top, do we just normally multiply the normal p and an n, right?
It's not the normal p, it's x. So that's like the amount of times, I'm pretty sure, time divided by n.
No, I'm sorry. Wait, no. Okay, I got confused, so it's okay, don't worry about it.
So with this one, I'm pretty sure because n is so large, p is going to be the same.
As the normal P?
I'm pretty sure.
Doesn't it say something about that in the reading? Well, earlier when we learned that the bigger that n is, the narrower the. Is that like the same concept? I don't even know what I'm saying, but
Yeah, if you look on the textbook under the sample distribution of the sample proportion, it says in 3.2.2, it says the sample proportion p with the triangle is normally distributed if n is large. The true population mean of the random variable p is equal to p. So that p with the triangle turns out to be equal to it if n is large. So
yeah, because it's 2,000.
yeah,
Yeah.
I'm pretty sure that's going to be the same. I don't know. I mean, I think it's worth a shot. We can just do 0.52.
Yeah, that's what I just put, 0.52.
But it says round to 3 decimal place, so it kind of throws me off.
Well, if we try to find the standard deviation of P, then we would do that equation, right? Or no?
The standard deviation one?
We do.
Yeah, you would just do, it would be that p 0.52 times 1 minus 0.52 over, what is it, 2,000?
Yeah.
Square root of 2,000.
So you got to put that in. So let me see what that comes out to.
I'm going to do it too.
0.52, right?
Mm-hmm.
Yep.
0.52. And then our sample size is 2,000.
Yeah.
Mm-hmm.
Okay, I got 0.011171. So 0.10, 0.01, 0.011.
Yeah, that's what I got.
Yeah.
All right, so that's the
0.11.
that's the standard deviation. So now we have to do the z-score of that, which is
Wait.
that's where it throws me out because we have to subtract the sample proportion by the true proportion.
Mm-hmm.
Yeah.
If they're the
And then
same,
you
then
could
it's
divide it by what? And then you.
they're divided the standard deviation.
That's going to be like.
It'll be 0 then, because if we have the same, then it's going to come out to 0 because they'll divide it by 0 and that'll all be 0. So
Wait, you take the whatever triangle P minus normal P. Is that what you do?
Yeah.
Yep.
That gives you a negative
46.
What did you
How
use
did you
for
guys?
numbers?
Yeah. How did you guys get that?
We just plug it in.
Because if we have the same mean or the same sample mean and true population mean, they would cancel each other out, wouldn't they?
Dude,
Yeah.
I get like negative 0.000254. It's like a basically approaching zero number, you know?
Okay, well, let me see if I get the same thing.
Well, I didn't have the triangle P put it in,
Yeah.
but
Yeah.
if I put it in, it's 0.
0.
Yeah, it's gonna be 0. But then it's like if you want to know like the real answer, it's like 0.000004 something. It's like basically it's 0.
So Celeste, what did you use for the number? The numbers.
So you take the normal, or yeah, triangle P minus the normal P, and then you divide it by n, right, guys?
Yeah. But
Mhm.
what did you use for the triangle P and the regular P? That's what
Triangle P I used 0.011. The one that we got, the standard deviation. Oh no, never mind. I used the wrong answer. What is triangle P?
That's what we're.
Dividing.
Yeah, never mind. I'm totally wrong. I wasn't thinking. Okay,
Yeah, I don't know. It's hard. Oh, it's not asking us for that, though. You got
it
that
says what
wrong.
z-score would you use, right?
Well,
Yeah.
z-score can be 0. It's just probability is going to be 50%.
Wait, so if we're trying to determine z-score, I'm trying to remember how to find z-score. I'm like confused now.
Oh, the z-score is that formula that we're just doing.
Yeah, it's the P with the triangle minus P divided by the square root of P times 1 minus P divided by 9.
Yeah.
But I just don't know
Yeah,
what.
if we have the same mean population and sample, then it's going to be 0 because they
Yeah.
cancel each other out.
So we think it's 0?
So if we do a z-score of 0, then getting less than 50% is 0.50.
So the z-score is 0.50?
No, the z-score is 0.
Oh, just 0?
But yeah, it's, I don't know how. I don't know.
I know, it's confusing because it says round to the 3 decimal places.
I'll try it and I'll let you guys know if it's right or wrong. Let's see what I get. Okay, so 3 we got right. 4.
Wait, did you get 16? What'd you get for 16?
I got 0.5.
0.5?
Yeah.
Yeah.
So how did we do?
We missed 15, 16, and 13.
Okay.
Okay, let's start on 13. So it's not 0.862.
I wonder if we have to shade it to the right of it.
Yeah, that's what I'm thinking.
So
Why?
probability 1.091.
What?
So
Oh,
what is,
yeah, it should. No. It has to be to the right because it's at least. So it wants to know.
okay, so that would be
Yeah.
wouldn't that be 0.138?
What did you say?
I got 0.138 on that then.
I'm pretty sure it is to the right because if you're thinking of like, that's the least amount that she could get. But if it was like, if it's the most that she could get is 35, then it would be to the left. I don't know. Does
Oh,
that make sense, guys?
that makes sense then, yeah.
Does that make sense, guys?
Yeah.
Yeah.
Yep.
Let's put them in there. That was 13, yeah?
Yeah, 0.138, right?
Yeah.
0.1138.
And we got number 14 right?
We got 14 right. We just didn't get 15 or 16.
So what did we use for P for 14?
We assumed that it was the same as the P, like P with the triangle was the same as normal P because the sample size was large enough.
So if we assume, I don't know,
Maybe we have to assume that it's saying getting less than 50% of the votes. So it has to be 1,000 divided by 2,000, right?
Yeah.
So wouldn't that just be 0.500 for that?
For the z-score?
No, for the
P.
For the P?
for P with the triangle.
Triangle P?
Yeah.
Wait,
If
no.
you-
Wouldn't our triangle P be 0.52 since question 14 saying that? Oh no, never mind. Yeah, you're right.
Well, we tried 0.52, and that gave us wrong answers.
So if we put in what is you said, 050 or whatever?
Yeah, so it's like 0.500.
0.500.
That would give us a difference between the two. I don't know. I don't know if I'm making sense or if it's just confusing.
No, I'm listening.
So let's just say, because what it's saying right here is we want to determine the probability that the results of the survey will suggest that the candidate is losing the election. So getting less than 50% of the votes. So if you have a sample size of 2,000 people, at least half of them or less have to vote for that person.
Yeah, you're right.
So if you divide 1,000 by 2,000, that gives you 0.500. Then if you do that with the other two questions, so the z-score will change. Z-score won't be 0 because we'll be doing, what is it? The square root of, no, sorry. Z-score would be 0.50 minus 0.502 divided by the standard deviation, which would give us a different answer than 0.
It still gives a 0?
What?
I said, did you still get 0 with that?
No, I'm redoing my test and trying to see if I can do that as well.
What I just did, I got the standard deviation as 0.016. Wait, hold on.
And you're assuming that our P with the triangle is 0.50?
Mm-hmm. No, the other way.
For my z-score, I got negative 1.790.
Wait, what'd you put triangle P?
0.50.
Okay.
0.50.
5. And then P is 0.52.
Yeah.
Yeah, P is 0.52.
Yeah, I got negative 1.79 as well, and my standard deviation was 0.011. So that one was still right. We didn't get that wrong.
Negative 1.79 for z-score. And then...
Oh, okay. I think I got it. You guys used 1,000 as a n, right?
Yeah.
We need to use 2,000.
Or no. Didn't you guys use 2,000?
That's what I
used 1,000 divided by 2,000.
Yeah.
Oh no. That's for P with the triangle. I used 2,000 for my n.
Yeah.
So I got a standard deviation. We got that one, right?
Number
14.
That's correct.
Yeah.
0.011.
So I got z-score as a negative 1.790.
That's what we got as well.
Yeah, that's what we got.
And that would change our probability if we said it's negative 1.790.
What'd you say?
We
have to have it losing from that, so that's 0.037.
For the probability?
That's what I got. Because we shade everything to the left of it, right?
Yeah.
Yeah, I got 0.037.
Yeah, that's what I got too.
So if one of you guys wants to check that and see if that worked, I'm just gonna get my questions.
1 second.
1.1.
Yeah, that's right. We got 100%.
Sweet.
So 16 is 0.037, right?
Yeah.
And then 15 is negative 1.790.
Or just
Okay.
negative 1.79.
Okay.
5.
Let me just make sure. I probably filled in something wrong like I usually do.
Yeah, I'm double checking all my answers.
So, hey, I got cut out. What'd you guys get on number 16?
0.037.
So we got 100.
0.037?
Yeah.
Yep.
Yeah.
Okay, yeah, that's
Okay.
what I got too.
See you guys later.
Wait,
Okay. Oh no, sorry, I was talking to somebody.
oh,
I wasn't talking because don't worry, I wasn't gonna cut off our thing, man. Don't worry.
Yeah, before we go, I gotta talk to you guys about the assignment that we have due this weekend.
So, oh yeah, we are doing our project, right?
Yeah.
That real quick.
Yeah, I'm just gonna make sure that I got all these answers right really quick, and then we can talk about that. I just gotta.
so
We have an assignment this weekend?
Yeah, so at the end of the semester, it's not showing up on our
oh,
thing, but at the end of the semester, we have to have a project, like a final
okay.
your own statistic.
Okay, so you're not talking till the end of the semester yet?
Well, we have to do something this week, and then when there's something due in week 11 and 13, and then I think 15. So it's something that we all have to work on together.
Oh no, it says 9, 11, 12, and 13 week.
Yeah, you got it. Sorry, there's no 15 week in our semester, so. So basically we have to decide what each person wants to do. Aside from collecting the data, we all collect the data together.
Mm-hmm.
And each of us has to do a write-up on every other part. And so first we have to decide what our study is going to be. And then we have to get that approved by Brother Bennett because apparently it takes like 3 or 4 times to get it approved because it has to
So where is this assignment at? Like
It's under. You go all the way down to
Yeah,
the
you
final
go to your
project over. Yeah.
table of contents first. Go to your table of contents first, and then go to the very bottom of it, and it'll say final project. And the first thing that's to do is to design the study. But you have to look at the final overview. It'll tell you kind of what we have to do, what is expected.
Oh, so what's the first thing we need done?
So the first thing is called the design the study. And basically what we have to do for that is there's like a Word document that we have to fill out. And I've already started working on it, just putting our names in it. But basically we have to determine who's going to do a main writing for designing the study. That's due this weekend.
Mm-hmm.
Everyone has to write up and submit their collect the data document. So we all have to do different collections of data. And then we have to have somebody describe the data. Somebody has to do making an inference. And then we have to do a take action. And then it also looks like we have to do a PowerPoint presentation. So it looks like there's 1, 2, 3, 4, 5 things. So I'm fine with volunteering and doing the PowerPoint one too.
Okay.
And then we all have to fill out our own group evaluation. So we have to evaluate each other and how we do. Which I'm pretty sure I'll give you guys all 100 on it because we work pretty well together.
So just real quick, the PowerPoint, is it just pretty much summing up steps 1 through 5?
I'm pretty sure. I think that what we do is we collect everything and everyone writes different pieces and then we kind of just put it in the PowerPoint and make sure it looks good and we have to present it.
So the PowerPoint's really easy. Okay.
I think so. Let me look at this really quick. It should be at the bottom.
Yeah, no, I'm looking at it right now. Yeah, that seems a little bit. So we need someone to design the study, then describe the data, make inference, and then take action.
Yeah, so we're basically doing that first thing that we learned in the first week where we break it all down for our statistics.
Okay. So
Okay.
what do we have to design our study? Like, what are there examples he gives us?
I can't remember if he gives us an example. Let me look at designing the study. You're to create your own research question based off the interest of the group. So here's a few examples. Are there 1,000 chips in every bag of Chips Ahoy? Are brand A paper towels stronger than brand B? So we could do an ANOVA test or a paired sample or different kind of things. Is there a difference in the prices of books at BYU Idaho Bookstore compared to those available online? State your research question. What populations are you studying? Basically, we just have to break down what we're looking for, who we're going to look for in it, and all that jazz. So I'm just going to put this out there. My wife and I are actually moving to Provo this week
Oh.
because I'm going to BYU this next semester. And so if we want to do like a comparison between BYU and BYU Idaho, I'd be totally down to go and collect data over at BYU.
Okay.
If that's something you guys want to do. If not, we can do something completely different.
No, that would be pretty cool. What would we discuss about? What would be our study?
I guess we kind of have to figure that out. What we could do is
Mm.
I can do the first thing. I'm willing to volunteer for this because I actually think it's kind of interesting designing or writing down the design of the study.
Okay.
Mm-hmm.
So I'll volunteer for this one, and I'll just turn this in on Saturday.
Okay.
So if we want to, what we could do is we could just think about different things that we might be interested in comparing between the two schools. And then tomorrow when we do our other meeting, we can kind of talk about what we want to do, and we can go through some of these questions and determine it together.
Okay.
Just so that we're not spending like another hour talking about all this stuff tonight.
Yeah. Wait, what were you thinking about comparing though? Did you have like ideas off the top of your head though?
I had two of them that I think they're kind of goofy, but I thought they were kind of fun. I was going to compare the difference between how many days an average student spends at the library on campus.
I like that.
Between the two. Or I was just going to do like a random, like buy 30 dum-dums and do like a comparison between which student, like how many we have that pick between two colors or two flavors and see like what the comparison is between like how many people would pick the blue one over the red flavor or something like that. That was just what I was kind of figuring, but
No, I kind of like that idea.
I don't know.
I like both of those ideas because like the library one would be good, and then I work at like I told you guys I work at the fitness center, so like that sucker idea I could do just after people leave. I could just say, hey guys, before you leave, can you do a quick survey, and I could get a ton of people to do that one too. So
Yeah.
I'm good with either one of them.
How would we make sure that that's random sampling? Because like, I think that those would be really easy to do random sampling because it's not like we're picking a certain population. I just want to make sure that like we're getting like super accurate data. We don't have to like for that. We wouldn't have to like not give them a dum-dum if they're a freshman or something like that. That would be pretty much we could just give it to whoever. Right? I just want to make sure that that sounds correct.
Yeah, we could just do random. Random sampling usually is what
Everyone
I
does
don't
it.
know from the reading we've had. Seems like random sampling is okay.
Yeah.
I feel like random sample just gives us the best. It prevents like bias from anything. So, but yeah, I'm totally willing to volunteer for the being the main writer of designing the study.
Okay.
So let's talk about this tomorrow. Celeste, will you make sure that you put this on the video on the group collaboration page?
Mm-hmm.
And then tomorrow we'll talk about what we'll kind of, you guys can kind of think of different ideas too, and we can kind of talk about what we want to do for our studies.
Yeah, we can all talk. I think if each of us comes with like at least one idea, I think that would be good. What do you guys think?
Yeah, that would be perfect.
And then we can choose between all our different ideas.
I think that's a great idea.
Okay, because so we just decided that all of us come with at least one idea tomorrow.
Okay.
And then we'll vote on or decide which idea we like sounds the best.
Okay. So,
Does that sound reasonable to you, Kazuya?
I don't know. I got cut off a lot of times. So,
Oh,
so are we just
I'll go for it.
comparing the BYU and BYU Idaho with something with this fitness stuff?
Well, that's what we're talking about. Tomorrow we want everyone to come with an idea of what they think would be a good study,
Oh,
and then we'll vote on which one we want to do.
okay.
We'll go into detail about what, like, is it a quantitative test? What kind of test are we going to use? Like a sample t-test, a NOVA test, basically seeing if there's a difference, or expecting that BYU would have a different outcome or greater than or less than. So we'll do that tomorrow.
Okay.
So just come with an idea that you think would be really interested in studying, and then we'll go through all those questions and stuff like that.
Okay.
That makes sense?
So we're
Yeah.
meeting tomorrow at 6?
Yeah.
Okay.
Alrighty.
Sounds good.
Okay, guys. Sounds good.
Okay.
I'll make sure I post this on the group posting. You guys have a wonderful night.
You
Talk to you tomorrow.
Alrighty.
Yeah. See ya.
See ya.
Yeah.